entries in the DACL for the resource that you've requested access to, it will basically skip all the access granting access control entries and only process the deny access control entries. You can also remove stuff from this list and create a smaller list, and you can actually add stuff to that list as well that wasn't there from the start, which is very interesting. And it's actually fortunate that you can, because it's the only way actually to deny access to certain system resources for this sandbox process. So when you've got a token, for example, the primary token of your process, and you've restricted it, removed all the privileges that you don't want to be there, you've perhaps added or subtracted from the SID list, you can take that restricted token and pass it in as the first parameter to create process as user. And create process as user is normally used by the system only to create new processes, and it assigns, make sure that the primary token of the new process is assigned accordingly. That's actually controlled by a system privilege. So if you don't have the SE token privilege, you can't assign a new primary token to a new process or to any process. But create process as a user called with a restricted token will actually allow you to start a new process with an arbitrary token, as long as it's a restricted token of the primary token that's created from the primary token of the calling thread, or sorry, the calling process. So which means that it's a nice way for you to actually spawn off a new process from your application that's dropped all the privileges the user might have had. So for example, on XP, if it was an admin user, you could drop the domain admins group from the SID list. You could drop all the privileges that he might have been granted from the restricted token, and then start a new process with those lower privileges. So basically, making sure that he doesn't have access to something that that could compromise security. So that's a very nice feature to have. It's basically the what's underpinning sandboxing in Windows is the restricted token. But there are other things, other resources that we need to consider when sandboxing, for example, untrusted code. So one thing that's interesting to look at is the GUI model. And the GUI model is built up of securable objects, objects with security descriptors. And they go from the user session, which is created at login, and within a session, there can be one or more Windows stations. And by default, there's only one. It's called Windows Station 0, Winsta 0. And this Windows Station all Windows Stations can contain one or more desktops. And by default, there are a couple of desktops created in the Winsta 0 instance. For example, there's the interactive desktop that you get logged into, essentially. And there's also the logon desktop, which is where you enter your credentials at the login prompt, and also where you get sent to when you press Control-Alt-Delete. Now, processes belong to a Windows Station, so they kind of map at that level. But threads can be assigned to different desktops within that Windows Station. And the desktop object is kind of interesting because it's kind of the lowest security, the lowest level securable object that we have in the GUI model, which means that the desktop contains all the GUI objects, all the windows on your desktop, message queues for those windows, and all the other GUI elements. But within this desktop, there is no access control whatsoever. So basically, two processes that have windows open on the same desktop have a way of talking to each other without there being any security involved at all. So they can, for example, post messages to each other's message queues, and these messages can be quite nasty. If you look up what's called a shatter attack, you can see what happens when a process posts messages to the message queue of another process that might have higher privileges. It can get it to do nasty stuff. With the 2000 terminal server release, there was a new concept introduced in the Windows security model, which is called a job object. And the job object is basically introduced to be able to set limits, resource limits on processes. So, for example, in a terminal services environment, you have several users that log in, and you want to set caps on, for example, CPU usage or memory usage, so that one user wouldn't be able to hog system resources and degrade the experience of other system users. So what Microsoft did was implement what's called a job object, which you can create and you can assign processes to it. And the job object can set a number of different limits. So it can set limits, as I said, on CPU use, memory usage, runtime of application, to prohibit hung applications or runaway applications. It can prohibit access to certain GUI objects that are above the desktop level, such as the clipboard, and prohibit access to sensitive APIs that might be used to compromise other processes. You can use it also to prevent access to granting new handles to UI objects of other processes, but that's not that doesn't give you very much. In Windows Vista, there were a couple of interesting developments. You've probably all heard of protected mode IE. Well, protected mode IE is basically running the whole of Windows Internet Explorer in a somewhat sandbox mode, where the the Internet Explorer process has been prohibited from accessing, writing to system resources, even though it's running as the standard user that's logged in. So, for example, if you were to subvert the Internet Explorer process using exploiting a vulnerability, you wouldn't be able to write to the startup key in the registry, for example, or something like that. And you wouldn't be able to write executables to disk outside of a certain temporary internet folder, temporary internet files folder, or something like that. And this is controlled by something, a new concept called mandatory integrity control. And this is mandatory in such a way that it's always checked when before granting access to a new system resource. And it's implemented in such a way that there's a new access control entry in the system access control list, which is called a mandatory label access control entry. And the mandatory label, the SID, if you remember in the access control entry, the SID in the mandatory label access control entry doesn't identify a user or a group. It actually identifies what's called an integrity level. And this integrity level is basically a number from 0 to whatever. And there are a number of different default assigned numbers with names such as low, medium, medium plus, high, system, and so on. The attributes in the access control entry specify a policy. That can be one of no write up, no read up, or no execute up. In Internet Explorer, protected mode Internet Explorer, it only uses the no write up policy, which means that this process running under a lower integrity level cannot write to objects that have been tagged with a higher security, higher integrity level than low, which is what protected mode Internet Explorer is running as. So most system resources are by default tagged with the integrity level of medium. Rather, if there isn't an access control entry with a mandatory label in the system access control list or SACL4 in a specific resource, it will be interpreted as being of integrity level medium, with the no read-up policy, except for processes which will be interpreted as integrity level medium with no read-up and no write-up. Sorry, I got that wrong. No write-up, no read-up for processes. For every other object, it's no write-up, of course, same as the what I said earlier. And the reason why processes also have the no read-up policy is to prevent a low-integrity process from reading sensitive memory from a higher integrity level process, such as maybe passwords stored in memory or something like that. And anybody can set a lower integrity level on a system resource. Anybody that can actually set permissions on a resource can set a lower integrity level than that process or thread themselves is running as. To actually raise the integrity level of a resource or a process, you'd need a specific SE relabel privilege to do that. So this is something that can be used to strengthen the sandboxing of your process that's running untrusted code, or rather parsing untrusted input, to make sure that if somebody were to gain execution within that process, they wouldn't be able to, for example, write to system resources or whatever policy that you've chosen to implement. Another thing that you probably all pretty familiar with at this point is user account control, which was also introduced in Windows Vista. And the idea with the UAC, I'm not going to talk too much about this because it's not really relevant to application security, more than that you need to be aware of it as an application developer. The idea is the admin users before had always basically logged in and had all their privileges, all of their domain admin groups and everything enabled in their access token. And as you might imagine, people were surfing the web as domain admin accounts and stuff like that. Home users were logging in as local administrators and stuff like that. So that wasn't a very good idea, since any exploit in a web browser or email application or whatever could then use those privileges to take over the computer. So what Microsoft tried to do is force third-party developers to not assume that the user would have these admin privileges. So, for example, not assume that you're on Windows 95 or whatever and start writing configuration files in the program files directory and stuff like that, but actually use the user profile and the HKey current user type of the registry to store those things. And it's interesting, at least, to mention how they did that. They introduced in the token something called a link token. And basically what that means is that a token can have a flag set that says that this token is basically a lower level token of an administrator or something like that. So it would set a bit in a bit field, flag field, and it would set a pointer to another token that is the actual token of the system administrator with the privileges of the system administrator that have been restricted. And as you remember, the process can't itself change its primary token. So they also introduced a new service running with system privileges called the App Info service. That is triggered by the Windows GUI or the Windows shell when it, for example, sees that this might be a setup program that you're running, or you're trying to copy files to a directory which you're not allowed to write to. And the Windows shell or Windows UI components would then call into this App Info service saying, we need to request elevation for this particular thread that wants to copy files to a protected directory or something like that. And the App Info service would then, first of all, switch to the logon desktop, protected desktop, and display the credential prompt. And for a logged-in administrator, this would actually not be a credential prompt. It would be a consent prompt that you've